Hello everyone, and welcome back to today's another topic. So today I'm studying for array and matrix using for NumPy. So NumPy is essential library for numerical computation in Python, and I will support the basic of array and matrix for this example. So first of all, here I'm creating and manipulating for is a one-dimensional array. Okay, so now let's get started. So first of all, here in this insert, I'm defined for inserted as an import to NumPy as an NP library. And so I'm creating a first simple on a dimensional array, and it defines perfectly just type np dot declare this is the app array. Okay. And so here's in this insert, I'm declare the sum of array 1, 2, 3, 4, and 5. Okay. And it's step print for this is called the original array. Okay. So now I'm creating accessing for element. So first of all, here I'm print for another print function. In this insert, the type for here is called the first element. Okay. And then here I apply for this is an array and use for index of 0. This means it's perfectly done, and you can use this print function and then create this double quotation, and the type for here is lost for this element. And create this clone, and then apply for here the array of indexing is decrement for 1. Okay, so this means in all of the code is created, so first is a one-dimensional array with this element for 1, 2, 3, 4, and 5, and export the first and last element using for the index. And this is how you can work with the basic array in NumPy. Okay, now there's some I'll save this code. Just press for this run button. So now with, as you can see here is a see for the result. First is a print for the original array. The first element is 1 and last element for 5. Okay, it's called the on-dimensional array. I hope you're understanding. Okay, this topic here I'm creating and reshaping for the two-dimensional array. The two-dimensional array, and let's see how we can reshape and here the code for that. So first I'm going for in this insert and define for perfectly. So for this array, and here I'm insert is a matrix. Okay, and is equal to apply for np dot define this is the array, and in this inside, first of all here I'm define the values 1, 2, 3. Okay, and next time apply for is 4, 5, and 6. So this is perfectly done, and here I'm just painting for is the original matrix, so it defines simply this matrix. Okay, and then go for the next step, and now just reshape for the matrix. So simple for this all of the code, and here I'm just type this is a reshape. So the public just type reshaped underscore this is a matrix is equal to define for here is a publicly matrix dot, and here I'm just type is a reshape this method, and in this inside I'm different with the values 3, 2, 3, and 2, and right here 4. So just get this double quotation, and here I'm typing this is a reshape for this matrix and create for the new one, and then I'm called for here if this is a reshape this matrix method. Okay, so you can see here I'm defined for this is a reshape. It's called it's two-dimensional arithmetic for this 2 row and 3 columns using for the reshape matrix, and it's transformed in the matrix with 3 row and 2 column, and reshaping is a powerful feature of NumPy. Okay, now just click on save this code, and just let's run this code now. So just you can see here is see the publicly output. So first to print for the 2 row, and see here 2 row and 3 columns, and reshape this is a 2 column, and here I have a perfect understanding. Okay, so this topic here I've simply defined is a matrix operations. So matrix operation is a create a matrix and multiply a matrix by a scalar. So you can see first I'm going for this insert and define for this matrix 1, and it's for the np dot array. So now just remove for the value of 3, and in this insert I'm define for only 3 and So okay, and now just copy for this line, add paste for the next line, and change for the value. So now here I'm inserted is a 5 and 6, and remove for this one, and here I apply for the 7 and for 8. Okay, so this one is perfect. And now this change for is a matrix of T. And now first of all, I move for this paint function, and here I apply for the add is a matrix addition, and I'll just add. So first of all, here then type is a added underscore this is a matrix, and is equal to suppose I apply for a matrix 1 an additional operator and the matrix of T. Okay, so this one is perfect, and so here paint for, and on the paint this is the add matrix. Okay, this one is perfect, and so here on page is a multiplications this matrix. So first of all, here is defined for simply is a scalar. So this one, this is scalar, and score is a multiplied matrix, and use for here different for the matrix 1 and a multiplication sign for 3. Okay, so this one is perfect, and now here simply paint for this matrix. So just type is a scalar matrix. Okay, so this one is perfectly great, and like just and here you can see now just use for the underscore, and this one is perfect. And this means for this matrix operation is 22 matrices, add them together and multiplied another matrix by a scalar value of 3. And NumPy makes the operation straightforward and efficient. Now just save in this code, and just let's run this code now. Just press for here the run button. So you can see for simply error. So now just again perfectly just type. So this means for here now to define this code with is a new line. So it's just is perfectly just a matrix is a 3. Okay, so just check for perfectly is this one is perfect. It's a matrix 1 and then 2, and here just paint function inside. First of all, create this, and then type for is added this is a matrix. Okay, and create here colon, and then define for this new line. Okay, so this is perfect, and then going for again, and here I'm just type is a multiply, so double question and apply, and the type is a multiplied matrix, and create function and also define for this new line. Okay, so this is perfectly done, and like here again for select this all that code, and just let's run this code now. So you can see here is a Facebook name of the error. It's a scalar matrix is not defined. Okay, so now just take for here. So first of all, here define is a scalar multiplied this matrix is matrix 1 into 4 3, and here okay, you can see here page for this line is a complete error. Okay, so perfectly typed, so this one is perfect. So I'll just save, and then just let's run this code now. So as you can see here, perfectly painted for the output. Suppose it's paint added matrix, and here's a multiplied matrix. Okay, I have a proper understanding in this code. Okay, so now just simply done for this tutorial, and that is for today's tutorial understanding array. And the matrix is in for NumPy, and here I'm perfectly called for create and manipulate one dimensional array, ratio for 2-dimensional array, and perfect for the basic matrix operation. Okay, thank you for watching, and happy coding. Hello there, and we come back to today's tutorial topic. So today here I'm creating for a NumPy array. The NumPy is a powerful array for numerical computation in Python, and there are fundamental building blocks. So in the session, I'm perfectly created for this NumPy array. So first, I'm simply created for the creating arrays from the list. So the NumPy array from a Python list, and this is one of the most straightforward way to get started with the NumPy. So first of all, here I'm inserted for is a library is import for library as np, and now creating a NumPy array from a list. So first of all, here I'm just a type. This is a list of array is equal to different for np dot this array. Okay, and in this inside, different for the sum of the array is equal to. So now randomly is for this array. So now just different is perfectly is now. And then again for the next step, and just print for this array, and here I'm perfectly just type this is an array from list. Okay, you can see, and then I'm different for this is a list of array. So this means it's simply creating for in this array. And this example of first of all is imported for is a NumPy, and then creating an array from a Python list is containing the elements for 2, 4, 7, 8, 9, and 5, and np dot this array. This functions convert the list into NumPy array. Okay, so now just I'm saving this code down. Just let's run this code now. So they can see here, so there is a for the array from this list. Okay, I will be completely understanding this output. Okay, so this topic here I'm creating is a array with NumPy functions. So now here right now using for the sum of NumPy is built-in functions, and is for np zeros, np ons, and np arrange. Okay, so now just I'm close for this output. It is constant here. And first of all, going this. And first of all here, apply this is sequence. First of all, I'm going for here and just create an array of zeros. So define for here is a perfectly is called the zeros underscore this is an array is equal to. So here I'm just type np dot zeros. Okay, and in this instance I'm for the define for the value 5, and then I'll just print for is for print function, print for the array. You can see array of zeros, and now declare for this zeros. Okay, is it done? And now in this topic here, I'm creating an array of ones. So now different for perfectly is called the ons underscore is that array is equal to. So first of all, I'm type for np dot. So define is a perfectly ones, and like here is a pi. So in here I'm again use this print function, and first of all type for the matrices just type for the array of ones, and let's create this clone. And like here I'm define for this ones array, and lastly here I'm creating an array with a range of values. So now just type for the range underscore array is equal to define for np dot arrays is not array. This is an arrange method. So you can see just a perfectly type is a. This is the arrange right now. So now here I'm defining the value is 1, 10, and 2. Okay, and now here I'm again using this print function, and print for suppose the array with the range. Okay, so this means it's perfectly done, and here I'm defined for this range of array. So this means in this code, create for here is 3 different array. First of all, I define for np for the zeros functions. So functions generate an array of zeros with a specified length at np dot ones. This means this function does the same but with the ones, and finally use for np dot arrays. Create an array with a range of values starting from 1 to 9 with a step of 2. Okay, I'll be perfectly understanding this output. So now just I'm simply change for that value. So first time apply is 1, 2, 3, 4. Okay, and now just save in this code, and just let me run this code now. Just wait here. As you can see here, the first is print for array from original list, and this array of zeros of 0, and arrays of 1 is all 1, and array with a prints. So this is the range for 1, 3, 5, 7, and I have a complete understanding. So is a completely done and completely done for today's tutorial. So, and that's it for today's. This is a quick tutorial on creating a NumPy array. How I'm creating here right now is publicly cover how to create an array from the list using the NumPy function. Okay, so NumPy offer many powerful tools for creating and manipulating array and making it an essential library for numerical computation pattern. Okay, so if you can understanding this topic, so I just thank you for watching and happy coding. Hi everyone, and to come back to today's another topic. So today I'm creating here and export the basic and array operation using for the NumPy. So NumPy is a powerful library for numerical computation in Python, and array at the heart of it. And it is a video. Here I'm copy for the basic array operation for element for the array slicing. So first of all, I'm create the example for elements wise operation. So this operation are performed on each element of the array is individually. So first of all, I'm imported for NP for NumPy library. So first I'm create the two NumPy array. So first I'm define is the array is 1 is equal to. So declare this is a NP dot. This is the array in this inside for the value 1, 2, 3, 4, and 5. Okay. And instead of here, I'm create for another array. This is the array of 2. Different from NumPy, this is the array is not arrays. Here's the array. So inside, I'm used for some of value is of 5, then 4, 3, 2, and 1. Okay. So this one is perfect. And first of all, I'm used for element-wise addition. So just I'm type for add. This is a result. This variable is equal to. So first of all, I'm type for array 1 and then use for additional operator and then different is the array of 2. Okay. And now just use for print function and print for the addition. So just I'm publicly type for addition and create this command different. This is add result. And now I'm used for element-wise the multiplication. So just I'm type the more underscore. This is a result and is equal to. First time declare for array is 1 and then multiplication sign, and this is the array. So now I'm making use simply this print function and print for, so you can see print for this multiplication. So multiplication. This is perfect and make here and call this is a null result. Okay. So this means in this tutorial for this code, first of all, I'm creating for is a two array, this array 1 and array 2. And the perform for different was addition and multiplication. And the result the arrays each element and sum and pro of product of the corresponding element from the original arrays. Okay. So now just save in this code and just let me write this code now. So as you can see here, first is a print for additional result for is a 6, 666 and 666 and multiplication print for 5, 8, 9, 8, 5. Okay. So this is the output for in this code. So it's a done for is on its element operation. Okay. So next I'm create is a array slicing this operation. So slicing allows us to access a subset of an array's element. So now just going for a create. So first of all, here is a create for another new opcode. So remove for this opcode, and first of all, here I'm type this array is equal to create for np dot this array, and in this inside, for the value is 10, 20, 30, 40, and 50. It's perfectly inserted, and now I'm using this element from index onto fill. So the sum after slice underscore. This is the result is equal to different for array and used for the index for 1 and code 5. Okay. And so here I'm used for simply this print function and print for here just slice this array. So this one is perfect. And so here I'm called for this is a slice result. And so here I'm also creating for another step slice element with a step. So first of all, here type is the step underscore, and you can see different for slice underscore is a result. Okay, so it's done and is equal to. So first of all, apply for array and create this index for is a double clone and 2. Okay, and then here I'm used for this print function and print for this message. So post time app type this is a state slice this array. Okay, and then here I'm used for the step slice result. So this means in this alt code, first I'm create an array for this is and now here hit for the array and np insert for the sum of array and apply for slice result. And also here I'm define this step slice result. And now just select all essay this code and just let me run this code now. So as you can see here, see the result for first the print for slice arrays is 20, 30, 40, and 50, and step slice arrays print for 10, 30, and 50. Okay, so this is output. So now that's it for today's tutorial. It's completely done. And here particular for the code for basic. And even for basic array operation using for NumPy and cover for element wise operation, and also for the arrow slicing. Okay, so I hope you perfectly understanding this tutorial. So now just thank you for watching and happy coding. Hello everyone, and welcome back to today's NumPy tutorial topic. So today here I'm different expert for indexing and slicing arrays using for the NumPy. So NumPy is a fundamental library for the numerical computation in Python and understanding for how to index and slice array in the manipulating it efficiently. Okay, so now let's get started. So first I'm explain for basic indexing and create for the example using for the Python community version. Okay, so first time I'm define is a basic indexing. So indexing is allow you to access for individual element in an NumPy array. So now just create for a simple index example. So first of all, I'm going for this code inside and create NumPy array. So now I'm create for this array is equal to define for np dot this array, and in this insert I'm inserted for the some value 14, 20, 40, 40, 50, and 60. Okay, so this is perfect, and now X is for false element. So just type for this is a false underscore is element, and is equal to define for this array of index 0. Okay, and here I'm used for the print function and print for here. Just time this is the first element. And now I'm used for this clone, and the define is publicly this false element. So this is publicly done, and now here I'm just copying this code and paste for the next line and change for this. Now I'm apply for is a lost element. So there's some type for lost element, and is for array is decrement for 1. And here I'm publicly just type this is a lost element, and again apply for this lost element. It is okay, so now is it done. So just going, and here this means for in this code vertical NumPy array and access the first and last element easy for this indexing, and first element is add index for 0, and last element can be accessed using for index decrement 1. Okay, so now just select I save this code and just let me run this code now. So as you can see here, see the result. So first is the print, first element is 10 and last element is 60. Okay, so this is a public output. This is done. As topic here, I'm here is slicing for one-dimensional array. So this slicing is our UT access a subset of element from an array. Okay, so first of all, I'm going for here and inserted for the value is as for is a 70. So this is public, and here used for is a slice result. So just to going, and remove this. And here I'm just type this is a slice underscore. This is a result, and use for the array of index inside define for 1 and clone for 5. And now in this instead I'm change for this and publicly just type even for this masses, and here this is a slice array, and in this instead I'm getting for this square is a parenthesis, and in this instance I'm just type this is a index for 1, 2, 4, okay. And now just remove both this false element, and here I'm publicly installed this is a slice this result, and this step here I'm used for the slice element with a step. So just going this and remove both this one, and publicly just type is a step underscore. This is a slice underscore again, and then type this result. And right now here I'm viewing for this one and get for double clone for the value 2k. And then going for again just remove for this matrix and apply for this is a step for slice array and get this parenthesis and the type here. You can see this is every second piece, okay. So this means pop it down and before this last element, and here I apply for this steps slice result. And if you understand, here use create the slice the array to get the elements from the index 1, 2. So and also use for the strip slicing to get every second element from the array. Slicing a powerful feature for accessing specific parts of an array. Okay, so now I completely create my code and just select all and save this code and just let me run this code now. So as you can see here, serializer for the slice array index 1 to first print for the 20, 30, 40, and 50. This strip slice is every second element for 10, 30, 50, and 70. Okay, this is the output. So now it's completely done, and that's it for this quick tutorial on indexing and slicing array using for the NumPy, and cover for the basic indexing and slicing for one-dimensional array. I hope you're understanding this concept and will help you to manipulate and analyze data more effectively and with the NumPy. So now just thank you for watching and happy coding. Hello everyone, and to come back to our today's tutorial. So today I'll dive into the world of NumPy. It's a powerful library in Python for numerical computing and exploring for how to reshape and flatten arrays using from NumPy. Okay, so first of all, introduction to reshaping arrays. So reshaping array is a common task when it's working with data in NumPy, and it allows us to change the shape of an array without changing its data. So now let's add our first example. So first of all, you can see here I'm already imported from NumPy library. Okay, and so now I'm creating first with reshaping is a one-dimensional array, two-dimensional array. Okay, so first now let's just try. So first of all, here I'm declare this is an array, and use for is a one-dimensional, and is equal to create for np dot define this array. And in this insert, I'm insert for some array elements. So now I'm apply for 1 to 6. Okay. So you can see inserted for 1 to 6 this array. And the next step here, I'm define for perfectly is the array underscore is for the two-dimensional array. And again, use define this array. So you can see. So first of all, is not direct use. So first is create the array is a two-dimensional, and to declare for one-dimensional array dot just type here is the reshape now, and in this insert I'm creating for double collision different for the value. Our element is 2 and 3. So this means it's done, and now here I'm just print for this array. So first of all I'm printing for original one-dimensional array. So now just first of all here just a type. This is a original one-dimensional array, and to create this column. And now here I'm simply open for this one-dimensional array. Okay, so this is perfectly done. And now just here I'm copying this line and then paste for the next line. And here I'm just change it. So here I apply for a two-dimensional array. And here I'm just use for reshape a two-dimensional array. So now just a change for this original array. First time declare is a new line, and the create here is saved just a perfectly typed. So you can see here I'm inserted perfectly this reshaped two-dimensional array, and I'm declare for this is a two-dimensional array. Okay, so this means I'm starting with for one-dimensional array is containing for here the sixth element, and using for here the reshape method and convert it into a two-dimensional array with 2 rows and 3 columns. So now just verify this example. So first of all, I'm select all and save this code, and let's run this code now. So just wait here, and as you can see the results. The first is print on a dimensional array is 1 to 6 element, and reshape array for here is a 2 row and 3 columns. Okay, so I have a complete understanding. Okay, so that's simply done for reshaping. And next if here I'm using for the another example, just is create the flattening arrays. So flattening is a process of converting a multi-dimensional array into a one-dimensional array. So this can be used for simplifying this operation. So now let's flatten a two-dimensional array. So first of all, I'm just print for here and remove this. So just remove one-dimensional and perfectly inserted. This is a two-dimensional array. So you can see. So now I'm apply for another square bracket. So this one. So now just I'm closing for 1, 2, 3. Okay. And next I'm again apply for this square bracket. So and this perfectly done is correct. So plotting a two-dimensional array is a one-dimensional array. Okay. So this means perfectly done, and then going forward to change this array. So now the define for any underscore is a flattened. Okay. So flat just perfectly type it can see is a flat double T E N E D. So this means done, and apply for here is a remove for one-dimensional array. And now insert for perfectly two-dimensional array. And remove for this reshape method, and insert for here is a flatten this methods. Okay, so this is perfectly done. And first of all, append this is a original two-dimensional array. So first of all, here I apply perfectly new line. Okay, and then remove for one-dimensional inside the two-dimensional array, and change for this array. So first of all, here I'm just remove for this one-dimensional and instead of perfectly two-dimensional, and now just append for flattened two on the one-dimensional array. So just change and perfectly inserted for here. So you can see just change for reshape and inserted it for flattened. So FL is not correct. So FLA double T E M E D. Okay, so this means perfectly done one-dimensional array. And now just change for a two-dimensional array and perfectly inserted for this the array it is a flattened. Okay, so you can see here I'm start with a two-dimensional array. Use the flatten method to convert it into a one-dimensional array. This is completely done, and I'll just save in this code and just let me run this code now. So you can see here, so the result is also the print for is original two-dimensional array 1, 2, 3, and 4, 5, 6, and flatten to one-dimensional arrays perfectly is online is print for this output. So this means the elements of the two-dimensional array are now in a single row in one-dimensional array. Okay, so this is completely done, and that's it for today's tutorial. I hope you perfectly learned for how to reshape one-dimensional array into for the two-dimensional array, and how to plug it into multi-dimensional array back into the one-dimensional array using this NumPy libraries. Okay, so I hope you perfectly understanding this topic. So now just thank you for watching and happy coding. Hello everyone, and welcome back to our tutorial. So today we're going to explore forward with some fundamental operation in NumPy. Just like for is a joining and splitting array. So this operation are incredibly using for manipulating and preparing data in various forms. So now let's get started. So first of all, apply for example for joining array. So just introduction to joining array is allow us to combine from multiple array into one. So now let's start with for here is a horizontal stacking. Okay. So now import for is inserted for library is NumPy. Now create for example for horizontal stacking of array. Okay. So this means first time define this is an array of 1 and is equal to just type for here np dot and define for this array, and in this inside inserted for the sum of elements. So first time apply for 1, 2 and 3. Okay. So this means perfectly done, and now just copy in this code and paste for the next line and change for this call for array of t, and in this inside I'm changed for the values first time apply for 4 and 5 and last one this one is 6. So now here is a 2 array defined for 6th element. Okay, and now first of all here apply for array is a stack. So create for here array underscore then h4 stack. So stck is perfectly done as equal to, so bottom apply is np dot is for this the is stack. This method defined for this is not, so this one is a double is a parenthesis and declare for some apply is the array of 1, and secondly here define is the array of t. So this means it's perfectly done. So it's a complete equation almost in this code. You can see I apply for array and underscore for is tag, so it's perfect. And now post is print, so it's for the print function, and in this insert I print it for this is an array of 1. Okay, and next time I'll apply another print function and print for this array 1. Okay, so next line I'm just copying those code and paste for here and just change. So you can see first time apply for new line and declare for array of t, and again define for the array of t. Okay, so this means that perfectly done, and now print for another print function, and in this inside create for new line and then type this horizontal. So horizontally, so you can see is done. This one is great. Horizontal is tagged, so stck is tagged for this array. Okay, so it's perfectly done, and now here I'll simply use for print function and print for this array tag. Okay, so this means here I apply for 2-dimensional array. Sorry, it's a 2-dimensional, 2 on-dimensional array. So first is array 1 and array 2, and using for is tag method for just as combine them first horizontally into a single array. So now just stick all and save this code, and just let me run this code now. So just wait here. As you can see, you see they're perfectly painted. Supposed to paint for array 1 element and the array 2 element. Here is a paint for horizontal stack array is a under is a perfectly and so for the rest. Okay, so this means perfectly for the 2 array are joined for side by side into one continuous array. Okay, I hope you can understand this topic. Okay, so next topic here I'm curious is splitting array. So splitting array is a reverse operation of joining, and it allows us to break an array into for multiple sub arrays. Okay, so now let's start with the horizontal splitting. So you can see, so just I'm going for here and simply use for on array. So now just remove this. So you can see I'm completely, so you can see searchable for this line. And first of all, apply for is simply insert array. Okay, and keep for this np array in this insert. I'm inserted for. So now just remove this one. And first of all, here I'm get is a square double, square bracket just to use now. And in this insert, first is get the sixth element. Okay, so 1, 2, 5, and 6. Okay, so this is perfectly done. And then going for next step, and here I'm create for another element. The subtype is a 7, 8, and 9. So 9, 10, 11, and 12. Okay, this is public inserted. So now I'm going for this inside. I'm going for the array. Horizontal split. So split is done, and then use for np. Then hit for np dot for is a split, and in this insert I'm looking for some applicable array, and is for the 3 elements. And down first print for this original array. So count is a string of 1, and here first time apply a new line. Add print for this is original array, and then simply append for this array. And next line print for here, so simply remove for this code. And first of all, I'm get is a horizontal split array. So as split array, and now I'm here apply. So remove for this code, and here apply is a for loop. So for this array, so it's not now. So for array in just define for the array split, and now unprint for this array. Okay, so this means over here is a 2-dimensional array that is split for horizontally for 3 equal parts using for the horizontal split method. So now save in this code and just let me run this code. So as you can see here, see the result is perfectly printed. You can see supposed to print it for original array, and now is a printed for original split array is it 3. Line is perfectly printed. So this is the original array is divided into 3 sub array, and it's continuing for 2 column. Finally, just look at the vertical splitting. Okay, so it's perfectly done. So now there's the two just tutorial. So today I'm perfectly cover for how to join array using horizontally stacking and also a split array. Both here is both horizontally and vertically using for NumPy. Okay, so now just thank you for watching and happy coding. Hello everyone, and to come back to our today's tutorial topic. So today we're going to discuss for copying and viewing arrays in NumPy. So this application are efficient memory management and data manipulation. So now let's get started. So first time apply for copying array. So in NumPy, for the copying array, creates a new array that is independent of original. So now let's see at this example of how this work. Okay, so node is already import for NumPy library, and now starting for example copy an array. So first of all, I'm just type this is original array. Okay, and it's equal to np dot of this array, and insert for some elements. So first of all, apply this parenthesis, and also use for this square bracket inside, different for the total of 5 elements. Okay, now just type for here. This is can see this is a copied array, and is equal to, so this first of all apply for here is called the original array dot use for this is simply this copy method. Okay, so now it's done, and now here first of all apply is a print function, and in this inside and first print original array. So original this array, and now here inserted is called for original array. Is it done? And this topic, so step here used for again this print function as a double question and different for new line, and then type for here simply just type this is a copied for this array. Okay, and now use this comma and then define this copied array. So this means in this I could also create an array that's called for the original array and to make a copy of using for the copy method. Okay, I've been understanding. And now here I'm just select all and save this code and just let's run this code now. So just wait here. So now just publicly press. So as you can see here, so first to print the original array is a total of 5 elements, and copied array is for perfectly total of 5 elements is perfectly copied. Okay, so this means you're perfectly understanding. So is a copied array. It does not affect for original array. Okay, I have understanding. Okay, so now just move on the second topic. So now I'm creating here is a viewing array. So if a viewing in NumPy, on the other hand, is a new array object that looks at the same data as the original array. Okay, so now just let's see an example of creating and using for this view. So this means, so first of all, just going through here and just apply for original array and insert for total 6, 7, and add element and apply. So even for this copied method, and here I'm applying just simply this is a view method. Okay, and I just simply print for original array and this original array, and now just change for this copied array, and here I'm applying the publicly call is this is a view array. Okay, and hit for original array and use for this view method, and again just going through here and now simply just apply remove this copied array, and here I'm publicly just type this is a view array. Okay, and now just remove this copy. So now publicly apply this view array. So it's publicly done, and just select all and save this code and just let's run this code now. So as you can see, publicly original array is this one and view array. So here I'm used for the simply I add the topic. So now modifying for the view array. Okay, so this means, so first of all, just going for the next step and just type for here, select the view array and use for the index of 0, and 0 index I'm apply for element of print. Okay, and so I'm used for the print function again and apply for here is a new line, and now wait for here is a modified view array. So publicly just type it, this is a modified is a view array, and so I'm given for this view array. Now secondly, print for, so you can see just alpha. So now just select all and save this code again, and just let's run this code now. So as you can see here, see the result is modified view array 0 index for the element inserted, and now is 10. Okay, this is index 1, 2, 3, 4, 5, 6, and 7. Okay, so this is perfectly done, and here I'm creating a view of original array using for view method and modify the view and print for the change value of our element. Okay, so this means perfectly done in this tutorial. So here I'm perfectly applied for 2 topics. Okay, so now there's is for today's tutorial and cover the difference between copying and viewing array in NumPy. I hope you perfectly understand in this concept is essential for efficient data manipulation and the memory management. Okay, so now just thank you for watching and happy coding. Hi everyone, and to come back to our today's tutorial topic. So today diving into the world of NumPy to explore some basic mathematical functions. Okay, so NumPy is an essential library in Python that makes a numerical operation simple and efficient. Okay, so now let's get started and create for perform some fundamental mathematical calculation using the NumPy. So first I'm apply for the basic arithmetic operations. So the basic arithmetic operations is like I'm creating now is addition and subtraction, and also for can take for multiplication and division. Okay, so now is that NumPy is make this operation is straightforward. Okay, so first of all I'm going for is inserted is an NumPy library, and first time defined the array is 1 and is equal to, so first of all type is np dot define this array. Okay, so this means perfectly not, now this isn't right, so now it's perfect. Okay, and then going for here and this time applies a parenthesis and also use this square bracket. So I'm applying for some element 1, 2, 3, 4, and 5. And instead of here, I'm defining this is another array is defined, declare the array is 2, and apply for np dot this array, and inside insert for the some value is so is the element is a 10, 20, 30, 40, and 50. So now it's perfectly done and creating for 2 array elements. And first of all, I'm applying for additional mathematical operations. So first of all, here I'm just type is the addition underscore. This is a result, and is equal to use for np dot. The type is of this is the add method, and this inside I'm declare first is array 1, and secondly declare this array of 2 is defined, and now you use for print function, and this inside I'm print 4. So first of all I'm print this is a addition result. So this message perfectly inserted is the additional result, and so I'm declare is perfectly the addition result is perfectly done for additional mathematical term. And then here I'm apply for subtraction. So first of all, I'm perfectly type this is subtraction result. Okay, so this method perfectly done and is equal to apply for np dot use the subtract this method, and define for this array is 1, and secondly I'll define for array 2. Okay, and so now just I'm going for next step and use for this print function, and print for is a subtraction result. So subtraction result, and now define this subtraction. Okay, so you can try for a product division and multiplication. Okay, so now just here for 2 operations. So now it's completely done, and just I'm select all and save this code. And so let me run this code now. So as you can see here, suppose this is a print of 1 and additional result, and here this means a subtraction result. Okay, I be complete understanding and this topic. Different for 2 arrays, array 1, array 2, and use the NumPy additional subtraction function to perform the arithmetic operation on this array. This is done, and this topic here I'm defining is a create for, and the topic is a trigonometric function. I've explained now is a trigonometric function number provide a variety of trigonometric functions such as sine and cosine only I'm used. So just going through here, and first of all I'm apply for is a simply remove for solve the code. Okay, and first type is angles. Okay, angle angles is equal to. So first time I apply for np dot this is a array. Okay, and this means first of all here use for this parenthesis, and also is a square bracket. So first time define for the element is 0, and np dot is a pi value is a divide 2. Okay, again use for np dot only for the pi value, and also here I'm kid for the 3 is a addition for 3, and multiplication for np dot is a pi value is a divide 2, and here other create for the equation for this expression for 2 np dot this py, and this is done. And now first time apply for sine for the trigonometry, and the first time apply for the sine underscore is a result, and is equal to. So first time apply for np dot use for the sine method, and in this instance I'm different. So this means different. This is a angle. Okay, so it's done, and here I'm used for the print function and print for this sine result. So this means for this is sine result, and I'm different for this is a sine underscore result. Here this means it's perfectly done, and here it's just forced to lost this line code. Okay, so now there's some copy and paste for, so it's not now, so paste for this second line. Okay, So it's a extra. It's just remove, and here I apply for cosine result. So perfectly just type the cosine and then np dot cos. And this instead I'm different for this angles. Okay. So this is perfectly done, and here I'm apply. This is a cosine result, and remove this. Okay. And instead of for perfect this cosine. Okay. So in this topic is completely done. And this means, so first of all, apply for here and area of angles in radians, and is for the NumPy sine and cos. This function to calculate the sine and cosine of this angle. So now just select all and save this code, and just let me run this code now. So just see this the result. Okay. So this means you perfectly see the result. Suppose it's pinned for the sine result. This the value element, and the cosine result is here is a total this and a value for the result. I hope you completely understand this topic. Here is a completely done for this topic, and this is for today. And here are perfectly covered for the some basic mathematical function in NumPy, including like arithmetic operations and also the trigonometric functions. Okay. So this operation are fundamental for data analysis and scientific computing. Okay, I hope you enjoy in this session. So thank you for watching and happy coding. Here everyone, and to come back to our today's tutorial. So today we're going to explore for some essential statistical operations for using this NumPy. So statistical calculation is simple and efficient. Okay, so by the end of the video, you all know how to perform the math basic for statistical operations such as mean, median, and standard deviation using for the NumPy. So first of all, I'm creating for the mean of an array. So this mean in average of a number in the array. Okay, now let's see how to do this with in NumPy. Okay, so now is inserted is a NumPy library. And then here create an example for calculating for the mean value. The define for the data is equality. So apply for np dot this array, and instead for the sum of elements for is a 10, 20, 40, 40, and 50. So this was perfectly done, and so here created this is the mean underscore value, and is equal to first time apply is a np dot is a mean value, and in this method I'm different for data. Okay, so this method is perfectly done, and then here just paint for this value. So first of all, I'm used for this to paint the data. So now I'm called for this data, and the second line here I'm paint for the mean value. So first create the double quotation and different for a new line, and then type for here is a mean value. I'll simply define this as a mean value. So this means in this area of data is for here's a NumPy mean function to calculate the average value of the array. Okay, now just save this code and just let me run this code now. So as you can see here, see the result for the mean value average value for 30.0. Okay, so this is the output. So I hope you understand it. Okay. So it's completely done for mean value, and this topic here different for the topic. Just create is so here calculating the median value. So the median is a median value is in a list of number, and the list has an even number of elements, and the median is the average of the 2 million number. So let's see the section. So you can see different use for the same element. Just change for this one apply for this median. So this called the median value np dot is for this is a median value. Okay, so it's a done is perfect, and then going for here, and I'm just change for this. So I'm apply for this is a median value, and also change it for this one, and here I'm inserted this is a median value. So this means in this NumPy for median function to find out the median value of in this data set. Okay, so it's a completely done, simple code is done, and just take all I say this code and just let's mirror out this code now. So as you can see here, see the same value is the median value is 30. Okay, I will complete understanding. Okay, so this means here is a median value is 40. It's publicly done. In this topic here, I'm creating for another topic is called for now. So now I'm calculating the standard deviation. So first I'm simply explain for what is the standard deviation. So standard deviation is a measure the amount of variation or dispersion in a data set. And the low standard deviation means the data points are close to the mean. And while high standard deviation indicates that the data points are spread out over a larger range. So now let's calculate for here using this NumPy. So you can see I'm searching for some I'm inserted 50 and 60, 70, 80, and 90. It's just simple. And now I'm changing for this median value. Here I'm insert is a standard deviation, ST, and the type of deviation. And so now I'm changing for NP dot used for this is the STB. Okay, and in this method, insert I'm declare for this data. And first of all, I print for the data. Secondly, here is a print for standard deviation. So some change and then type for publicly STN, D or standard deviation. And right here, different for this is standard deviation. Okay, so the calculation is done, and here use the NumPy std function to calculate the standard deviation of this the data set. Okay, so now just save in this code and just let run this code now. So as you can see here, so the result is a print for first is print for the data all elements, and here is a print for standard deviation. The result is a 25.819 something. So this standard deviation is a data set is exactly 25.81. This tells us how much our data varies from the mean. Okay, I have understand this topic, and that's it for today's tutorial. So today I'm completely covered for some basic statistical operation using the NumPy, including for calculation the mean, median, and standard deviation. And these operations are fundamental for data analysis and scientific computing. Okay, so now just thank you for watching and happy coding. Hi everyone, and welcome back to our today's tutorial. So today we're going to explore for linear algebra using the NumPy. So NumPy is powerful library in Python that is simply by many mathematical operations, including for linear algebra. So first of all, I'm good for the first example. Okay, the matrix many is a multiplication. So first, let's look at the matrix multiplication. For the NumPy is made. It's easy to perform this operation with the dot function or the at the rate operator. So let's create this code. So first of all, I'm defining here the matrix multiplication. So first type is a matrix. What is it called to define for the basic form is the np dot this array, and in this inside. First of all, I'm used for the square bracket defined for the element is 1 and 2. And secondly, here I'm defined for the another square bracket inside declare for the element is 3 and 4. And now I'm copying this line and paste for just next line. And change for this matrix is for matrix 2. And in this element, change is 5. And 6, then 7 and 8. Okay, so this is publicly done. Now I'm using for is a dot function. So first of all, I'm just type for here casting result. I just go dot is equal to np dot is for the dot method, and this inside I'm defined for matrix 1. and also define this matrix 2. This is perfectly done. And now, first of all, I'm using this print function, and print 4 is a matrix 1. Okay, so just type this is a matrix 1, and use this colon and call for this matrix 1. Okay, and next step here, I'm just copying this line and paste for the next line and change for this, and now open for the matrix 2 and change for this. And now I'm create for this matrix multiplication result. So this for is another print function, and in this insert I'm just type for. So here I'm use complete a new line starting. So matrix is a capital word. Okay, it's a pub. And then here apply for a new line, and then here is a matrix multiplication. Okay, so multiplication result. And now I'm just trigger this result dot function. Okay, so now it's done. So now just will unset this code and just let me run this code. So the result is perfectly print. So first you print the matrix 1 element and matrix 2 element, and here's a print matrix multiplications. A result is equal to the dot, and print for the value element is 90, 22, and 43 and 50. Okay, so it's probably using for the dot function. And like here, apply for is using for at the right operator. So just wait for next step. And first of all, here I'm used for this result underscore set, and is equal to Cython for matrix 1, and is at the right operator, and define is a matrix to this operations. Now I'm used for a print function and define for the first is a new line, and type here you can see is a matrix result. Sequence is not great, so only use matrix result for using this line. Okay, and now I'm call for this the result set. Okay, so this means it's publicly done, and in this code I've applied for the two matrices, so matrix 1 and the matrix 2, using first time applied publicly working the dot functions, and now I apply for at the right operator to multiply this matrix. So now just I'm saving this code and just let's run this code now. So as you can see here, see the result for matrix is in at the right, and the value is 19, 22, 43, and 50. And so this is the same result is printed here. So I have a big understanding. In this topic here, I'm defined for solving a system of linear equations. So finally, I'm solving a system of linear equation using NumPy, and here I'm used for the linear equation or solve function is public for this task. Okay. So now let's get started. So first of all, here I'm apply to remove for this old code, and first I'm apply for the value a is equal to apply for np dot this is array, and in this insert I'm inserted for the some values. So first I'm print for 3 and 1, and secondly here I'm the square bracket is 1 and 2. So it's done. Now here I'm also create, so it's called for the coefficient matrix. So now I'm create for constant matrix. So define for b is equal to system type for np dot this array, and in this insert I inserted for element for 9 and 8. Okay, it's called the constant matrix. And now I'm solving for the system of equations. So first of all, here I'm just type is a variable isolation is equal to np dot, then type for li linear log dot use this solve method, and in this inside I'm defining for the value of variable of a and b. Okay, and some use for print function, and first print the coefficient method for a. Okay, and secondly I'm print for the constant matrix. So this time use is not right, is to simply use this print function and print for the constant matrix for B. Okay. And last time apply for another print function, and now use for publicly. So this means apply the new line. So it's not great. So this is a. So for example, I'm type a new line and okay, this is a solution. Okay. So now is it publicly type so solution for, and this depend for x, and now the squared clone, and now here I'm defined for this solution. So this means for the system of linear equation is represented by the first is the A for coefficient matrix and B for constant matrix. Use the linear. Here the solution function to find the solution. So I'll just click on save this code and just running in this code. So now just wait and see the results. Also the print. This is a coefficient and constant matrix, and here the solution for 2 and 3. Okay. I hope it caught understanding, and it's a print. So first equation for 2, 3 is a NumPy, is a linear equation function, make it easy to solve third system accurately. Okay. So now, and that's it for today's tutorial. So today I'm publicly cover some fundamental linear algebra operations using the NumPy, including for the matrix multiplication, calculating, determine, and for solving system of linear equation. Okay. So now these operations are the many scientific and engineering applications. Okay. So now thank you for watching and happy coding. Hello everyone, and welcome back to our today's tutorial. So today we're going to explore for two powerful features of NumPy. So first one is broadcasting and vectorization. So this feature allows you to perform this operation on array quickly and efficiently. So by the end of the video, you will understand how to use for broadcasting and vectorization to speed up your computation pattern. Okay, so now let's get started. So first I've created the example is broadcasting. So first let's talk about the broadcasting or the NumPy to perform for arithmetic operation on the array and different shape. As you know, let's see the example and how this work. Okay. So you can see here I imported already for the NumPy library, and so I'm creating for the example is the broadcasting. So different for the array, what is equal to is for np dot this array, and in this instead for the sum element is 1, 2, and 3, and let's see here used for another array is 2. Apply for np this array, and first time apply this parenthesis and use for this square bracket and different for a value of 10, and other element. Sorry, the element is not a value. Now apply for a third element is a 30. Okay, so this means it's perfectly done, and now here I apply the broadcasting addition. So as you can see, I'm inserted and this is our result variable is equal to first and define array 1, and is for additional operator and different for array 2. So now first is the print function and print for this array 1, and now I'm called for this array 1, this variable, and this line here I'm used for another print function, and perfectly apply this new line, and here I'm inserted this is an array of 2. Okay, and now I'm printing for this array 2. The down here applies a broadcasting addition result to use for another paragraph, and use this double quotation and also a new line and apply for is a broadcasting. So this is the anti BROAD broad casting this addition. So it's not correct. This is so it's a perfect addition result. Okay, so this means it's perfectly enter this additional result. So add t, so it's a perfect now. So additional result, and so I'm applies a clone, and so I'm called for this result. So this means if we here apply is a two of arrays. First one is array 1 and second one array 2. And array 1 is a one-dimensional array and array 2 is a means for two-dimensional array. When I add for this array for NumPy broadcast, the smaller added to master the shape to larger. So now I'm just to save all and save this code and just let me run this code now. So as you can see, suppose is the print for one-dimensional array is a print for one row, and here the two-dimensional is a print for three rows. First is 10 and 20 and 30, and here's now is a midpoint for broadcasting additional results. Say for is 11, 12, 13, and 21, 23, and 31, 32, and 33. This means the number NumPy has added for array 1 and each row is added to array 2. So this is a simple example of broadcasting in actions. Okay, this is done. In this topic here, I'm creating the vectorization. So vectorization allows you to apply for operations to enter an array without using for explicit load. So this makes your code more consistent and efficient. So now let's see this example. So first of all, I'm just create here and just remove for this array. So first of all, here I'm applying this is only data with a variable name and the type for np dot apply this array. And in this insert, I'm using for the parenthesis and also this is square bracket and insert for the values 1, 2, 3, 4, and 5. Okay. And now first of all here, different for is called the vectorization. And I'm creating here the vectorized operation for squaring each element. So you can see here, remove for this reserve variable and insert for is a square data. So SQUARED squared data. And remove for this array 1, array 2, and then type for here data. And is used for double multiplication, means the square is a 2. And first of all, paying for here the original data. So just in this line remove, and here I'm just can see just type this original. So original data, and I'm called for this data variable, and I'm for the square data. So just I will this, and here I'm changing. So just this is a type. This is a SQL square data, and then I'm called for this variable. So just perfectly type is called the code data. This means in this array for the data easy for the vectorization and can share the square is an element of array and in a single line of code without using this slope. So now the completely created by code and just select all and save this code and just let me run this code now. So press for the run button. So as you can see here, first print is original data 1, 2, 3, 4, 5. This element, the 5 element is a print for square data. 1 is square 1, 2 is square 4, 3 is square 9, and those 4 is square 16, and 5 is square 25. Okay, so this is perfectly using for this vectorization. Okay, so and that's it for today's tutorial. So I'm perfectly covered for how broadcasting and vectorization NumPy. It can simplify the speed of array operations. Okay, so this feature are incredibly using efficient numerical computation. Okay, so now just thank you for watching and happy coding. Hello there, and to come back to our today's new tutorial. So today I'm going to dive into the learning data from files using NumPy. So NumPy provides for convenient function to read data from various file formats, making it easier to work with the dataset in Python. So first I'm create for loading CSV file. So the CSV means the comma separated values of file are common formats for storing tabular data. NumPy is a load text function, make it easy to read data from CSV file. Okay, so you can see create is a loading CSV file. So this means so first create is an import NumPy library, and different for variable name is data. And in this instance, I'm just type for np dot here. I'm type this is load this text. Okay, and in this instance, I'm getting for you can just create for the data and name for generate data dot csv. Actually, and then here I also create this is a system type for you can see is a delimiter single question only use this comma, and then here just print for this. So first of all, just type for here you can see is a loaded for this data, and now it's simply just trade for this data. So this means when you press for in this right button and see the results. So here I'm not print because in this data I'm not right. I will be publicly step by step just explain. Okay, so you can see here the load text function to load data from a file name for the data.csv, and it specifies the delimiter as a comma sign, since the CSV file typically use this comma to separate the value. Okay, so you can try for another way. So you choose for is writing for the random data. Okay, so first of all, just I'm instead going here and remove for this np download text, and just I'll remove for this one, and publicly here I'm just type this is a random dot. Instead this is a rand, and in this insert for value 3 and 3. Okay, and so here I'll just change this, and instead this is called the generated. So NERAT generated data. So it's done, and now just simply select all set this code and just run this code now. So just wait, as you can see here is publicly. So the result is created for generated data. Okay, it's randomly used for data. The other way you generate for the publicly this data. So you can see simply undefined, and now just also undefined is up. So first period is a logic for CSV file. So now just define step by step loading text file. So the text file contains this structured or unstructured data in various formats. NumPy's iterate format text function is versatile and can handle for various file format. Okay, so you can see, so now just define. So first of all, just going for here and you for this brand this method. And first of all, here I apply is the right format text, and this insert area for this element, and just apply for a single question, and you save for the file name is data.txt. Okay, and also here I'm just define this is a delimiter, and this only use this. Okay, is it done, and just change for this, and it can here inserted for loaded data. So just type this is loaded for data and print for this data value. So this means that here I'm used for the generate format text function to load for data from a file name for a data.txt, and it specifies the delimiter as a count since our data is separated by commas. Okay, I better send that way. And say 30 here I'm get the loading data from binary file. So binary file is stored data in a format that is not human readable, making them inefficient large data set. So NumPy is a load function can load data from binary file created with the NumPy or same function. So you can see it's now the simple as array. So you can see is for the NP, and now just array for this all up in this code. Okay, so generate for NP dot use this is only the method, and in this inside I define for the file is data.np file. Okay, and now just see, so this means completely done, and here I've used for the load function to load data from a file name for the data.npy, which is a binary file. Here it's NumPy for the same functions. Okay, so when you just select all asset, and it's publicly see for the result in your computer. Okay, so now it's publicly done in this topic, and here and there's a tutorial. So here I'm publicly covered for how to load data from various file formats using the NumPy, including for CSV file, text file, and binary file, and also used for random data. So this NumPy function make it easy to work with a data set in Python, and regardless of the file format. I hope you understand it in this topic. So now thank you for watching and happy coding event. And to come back to our today's tutorial, so today we're going to explore for how to save data for file using the NumPy. So NumPy is powerful, the convenient function to save data in various formats, making it easy to store and share a data set. Okay, so first time apply for here is a saving data CSV file. So now discussing for how to save data in CSV file. CSV means a comma separated value. This is a file that common format to storing data, tabular data. NumPy's septic function makes it easy to write a data so CSV file. Okay. So first of all, I'm just going for this insert and just create for simple for just to check that this is a data is equal to create for simply this NP dot apply for this array, and in this insert declare for the sum of elements is 1, 2, and 3. And next time apply for here's at the square bracket and insert for elements 4, 5, and 6. And over here different is 7, 8, and 9. Okay. The public down and now apply for np dot use for here is a save text, and in this insert declare for data set. So just type for data dot, and here I'm used for this is a CSV file, and dot for this just simply use for LXX. Okay, this done, and then here apply for all this data, and then type for here is a delimiter, and use for is only this comma. Okay, and now here I use for print function and print for this message. So first time type for here is a data for saved to. You can see it's another start remove this, and in this inside I'm different for data dot this CSV. It's successfully okay. It's perfectly done and this successfully. And here I'm using for the save text function to save the data array to a file name for the data.csv, and specify for this delimiter is a comma, since for CSV file is typically used for commas to separate a file in this file. Okay. So now just select all and save this code, and just let me run this code now and see further result for data saved to data.csv is successfully. I hope you can understand. Okay. This topic here I'm different for saving data to text file. So the text file can store data, the structure or unstructured data in various formats. For NumPy, saved text function can also be used to save data in a text file. It can suggest change for this structure and use for the save text for data that only use for this the text file, and then also for data. Now I'm just remove for the delimiter. Okay. And going for here, and I'm just append for data save queue data without using for the text file as successfully. This means so here I'm use for the save text function to save the data array to a file name for the data.text, and to specify the delimiter, and the default delimiter is pasted here. Okay. So now just save in this code, and just again let's run this code now. So just wait. As you can see here, for the save data is data.text is successful. Okay, that will be understanding. Okay, so this topic here and different for data are saving data to binary file. This means if there is a binary file to store data in a format that is not human readable, is making efficient for large data data, and NumPy is saved function can be used to save data to a binary file. Okay, so if you understand, it's simply done, and then going for this inside, I'm just remove for this save text only used for the save method, and in this inside I'm just remove for this data.npy is a NumPy format, and then data, and also just going for here and change for this text, and here apply for npy is successfully. Okay. This means for here I'm completely used for the same function as to save the data added to a file name for data.npy. and this file will be is NumPy is native binary format. So now just I can save this code and just let me run this code now. So as you can see here, so there is a full data saved to a NumPy. For data to NumPy is successfully came. So this means in the 3 files completely working. So and this is work for today's tutorial, and here I'm perfectly covered for how to save data to file using NumPy, including for like the CSV file, text file, and the binary files. Okay. So NumPy functions are making it easy to store your dataset in different format, ensuring that your data is safely preserved in future analysis. Okay. So now just thank you for watching and happy coding. Hello everyone, and welcome back to our today's tutorial. So today we are going to explore for how to handle missing data using for NumPy. The missing data is a common problem in data analysis, and the NumPy provides for useful tool to deal with efficiently. Okay. So as you perfectly understand for how identify and handle missing data in your dataset using for NumPy. So now let's get started. So first of all, I identify the missing data. And the missing data is often represented by the special files like null for not a number. In NumPy, you can use a for NumPy function to detect these missing values. Okay. So first of all, I'm going for here and already inserted for NumPy library. And first of all, identify the missing data. So here I'm apply for data is equal to create for the new data for np dot inserted this array. And in this inside, use a for square bracket and define for the values of 1 and 2. And then here I apply for is np dot. This is none. No, here a number. And here I'm doing for 4 and 5. So you can see. So you perfectly notice that here is right now is not that this condition. Okay. So now I'm using for print a function. And first of all, here I'm just typing this is original data. And so here I'm different for this only this data. Okay. And next print line here I'm printing for is simply create this and apply for a new line, and define for here is identifying missing data. Okay, just I'm type for ID, so ID en identifying so missing data. Okay, and here I apply for, so it's done, and then I'm going for the next step and create for simple is another print function, and in this instead I'm print for np dot is for is this block, so is a none, and this instead I'm define this data. Okay, so this means for here in this array for data with some missing for values is represented by n dot none, and with the NumPy is a none functions. So identify this missing values. Okay. So now just verify. So simply just select all and save this code and just let me run this code now. So as you can see here, see the result for this means. So first of all, print for here is the original data 1, 2, 3, and values skip and 4, 5, and identify the missing data false. So this here and this one is third position is a 2, and here is a true means is a perfectly identified for the missing data. Okay, I be understanding. Okay, so this topic here I'm defining for is a handling missing data. So this means for handling the missing data, just a number. NumPy is provided for the function to replace the missing data value or remove them from the dataset is all together. Okay, so for example, used for handling for just in this main data used for this same element, and then inside just I'm going forces to replace the missing values with a specific values. Okay, you can see first of all here and then type for this is a data and underscore this is replace. Okay, replaced is equal to define for np dot this none, and underscore for here is a 2, and again underscore is a number. Okay. In this insert, I'm forced to define is a data, and also here I'm defining for this is a none is equal to decrement 1. Okay, so this message is done perfectly, and right here I'm used for handling for missing data. So you can see, so now just remove 4 in this line. First of all, I'm create a new line for handling for missing data, and here I'm just to create for replacing with 1. Okay, so and there's a parenthesis instead I'm different for -1 is it when the replacing with the negative is 1, and the current print for, so simply I'm used for this is the data. So just I'm used for another print function. This instead I'm different for data underscore just replace. So this means here is publicly replaced. And so here I'm just to save it this code and just let me run this code now. So as you can see here is identify the missing data for 1, 2 is decrement 1. It means that here in this element perfectly is missing. Okay, I will understand. And now here I'm remove for missing values from the data set. So now here I'm create for another variable for data underscore, and here I'm type is a remove. So remove is equal to different for data and use for this. Okay, so this means for, and here is for this line. Okay, and in this insert different for np dot apply for is a none, and this insert declare for this data. Okay, and like here I'm just copy in this line and paste for here, and now identify for missing data using for here the remove this file. Okay, so I just going here and you for value, and then going for, and here use for this is data removed. Okay, so this means first condition for replace missing value using for this basic value using the NumPy num to number. Okay, this function then just ring for missing value from data set using for Boolean indexing. Okay, so this means publicly done, and now just I'm saving this code and just let's run this code now. So as you can see here, so the result for identify missing data, and here you can see publicly remove and publicly print for 1, 2, 4, and 5, and here I'm publicly remove this decrement 1, or here use for the position for 3. Okay, so I have a complete understanding. So that here, that's it for today's tutorial, completely done. And here publicly discuss on handling missing data using for NumPy. And I hope you probably learned for how to identify, handle this missing value in the data set and efficiently. This essential assuring the accuracy and readability of your data analysis. Okay, I hope you probably understanding this topic. So now just thank you for watching and happy coding. Hi everyone, and come back to our today's tutorial. So today we are diving into the fascinating world of structure array in NumPy. So structure array allows us to work with the heterogeneous data and where each element may have different data type. Okay, so now we have perfectly understanding for structure arrays work and how they can be used in real world scenario. So now just jump right in. So first of all, I'm creating here is a structure array. Okay, so is a structure array can have different data type for each element, and different for data types using for data type specifier. Okay, so first of all here I'm creating is a structured array. Just going for different for data is equal to use for np dot this array, and in this instance first of all I'm used for this parenthesis. Okay, and then different for here is the NumPy is 1. Okay, and different for the name just use this name is Alice. Okay, and also instead for Alice is ages 25. So this is perfectly done, and now just copy. So you can see this is not create this parenthesis was this. Here's this curly bracket remove and instead for this parenthesis, and I'll just here I'm copying this code and paste for the next step, and here, and now you can see just now change this name. First of all I place the name is Alice, and now instead for another name is Bob, and then is it to different for age is 30. Okay, and also here I'll default number as 3, and then change for the name. So I'm searching for name is Charlie. Okay, so you can see the publicly just type is a Charlie, and then say change for is 35. So this means perfectly done. And then going for next step. And now here I'm just type, this is simply I'm create the d type is equal to. So here, first of all, I'm used for a square bracket, and in this insert, I define for this parenthesis, and first time declare is a id, okay? id is an integer type. Secondly here, define for this is a name field. So the name is a string type. So here I'm used for simply just define for u for 10, okay? So this is done, and now here I'm create for another parenthesis, and in this inside I'm define for this the age column, and the age is also for this integer type, okay? So this means it's perfectly done, and now here I'm print for in this array, so use for the simply print function, and the type for is called the structure. So struct structured array, okay? And then it's done, and now here I'm simply call for this data. So this means, so here I'm simply create a structure array with for the three fields, just like is the ID, name, and the age. And the ID and age is this field is integer data type, while the name field has a Unicode string data type. Okay, so now just I'll select all and save this code, and just let me run this code now. So just as you can see here, see the result for perfectly print for the structured array is one this ID, and as is age is 25, and here is a simply done for in this array. So here I'm perfectly creating for the structured array. Okay, so this is perfectly done, and I have a perfectly understanding. Okay. So now here I'm creating for other options. So now I'm existing for a specific field. Okay, you can see. So just I'm cross this and going for next step. So first of all, here I'm using simply print function, and print for here is a new line. So now I can create access and manipulating the structured array. So first of all, here I'm create the new line, and then type for this accessing. So accessing for a specific, okay, so it's not correct. So it's a right now, right now is a correct specific fields, and next step I'm used for another print function, and in this inside I'll declare for this is a names field, okay, and use this clone, and I'm declare also the date, and square brackets inside single quotation define is define this again this name, okay. Now just going for here and copy in this line, and paste for here is the next line, and just change. So here I apply for the age, so age, and the inside I'm again define for this age, okay. So this means for access the name and age field of the structured array, and print for their values, okay. So now just select all and save this code, and just let me run this code now. So as you can see here, see the result for accessing a specific field, names for Alice. These are names for Alice, Bob, and Charlie. Age insert for 25, 30, and 35. Okay, so I have a complete understanding. Okay, so this means so it's completely done to this tutorial, and this is for Vargar exploring a standard array in NumPy. And here you will perfectly learn for how to create, access, and manipulate this structured array, which can be incredibly useful for handling heterogeneous in data in Python. Okay, I hope you perfectly understanding and enjoying this topic. So now just thank you for watching, and happy coding. Hello everyone, and welcome to our today's tutorial on using NumPy for image processing in this tutorial. Okay, so now I'm covered for the basic example to show for how powerful and versatile NumPy can be for manipulating for this image. So now just let's get started. So first of all, quickly for review for what NumPy. So NumPy is a powerful fundamental package for scientific computing in Python. It's provides for support for array, matrix, and many mathematical functions. Okay, So now I'm create the context image processing, but NumPy is manipulate pixel data efficiently. So first of all, I'm converting an image to the grayscale. So the grayscale here, I'm just create this code. So first I apply for is the libraries and NumPy publicly import, and from here I'm inserted for another library use. This is a image. So this one is publicly, and now another library just import. So first of all here I'm used for matplot library. Dot is for simply just py plot. So this one is py plot splt. So this is publicly inserted, and now a lot for image. So suppose here I'm different for image is equal to just used for the image u dot. So I'm publicly used for the dot notation, and then type for this is an image read option. So this is publicly inserted, and in this insert I'm get for the color. Just apply for the color underscore. This is the image dot for JPG. Okay, so this means publicly done, and now convert for here's a grayscale image. Okay, so you can see. So first of all here I'm just type this is a gray for underscore. This is a image, and is equal to just type for np, and is for this dot notation, and this inside I first of all define this image, and is for also this is curly bracket. So first of all I'm used for the 3 dot, and then apply for a space and clone 3. Is a first step is done, and I here again use for this square bracket. So in this inside get for a grayscale just notation, so define for 0.2989, so 2989 is it done, and also here I'm get just like is a 0.58 and 70, and then here I apply for 0.411 is 40. So now it is publicly inserted, and now just display for grayscale image. Suppose I apply for a plot. Just here I'm just type for image. So this method and in this inside I first of all define figure just like is a grayscale image, and also create a fill C map. Okay, so C map equal, and in this insert I'm different for this is a gray image. Okay, so this image is publicly done, and I inserted for this plot, and so it's for the title, and then first time I apply this single quotation in grayscale image. So this light is a gray scale, so you just type for grayscale of this image, so you can understand. And then here I'm also use for the plot dot this show method. Okay, so this means in this for the loaded color image using for this is image do dot I am this rate, and then the just convert to the grayscale by applying for here is a dot product with a coefficient, and here in coefficient represent for contribution for red, green, and blue transfer respectively. And now just select all and save this code, and just mirror out this code now. So just wait for here, so you can see it's publicly opening. So just wait, simply open. This is publicly opening for this image. So it's called for the grayscale image. So I hope you understand it. So now I'm going for the next topic. So here I'm defining for another image. So and I'm create for image negative. So I'm create for here a negative of an image. So just go for here, and again is for this. So just close it down, and first use the load image, and then create for a negative image. So you can see. So first of all here for this line of code, and first of all here I apply this is a negative. So this is publicly inserted for the negative image, and is equal to, so now I'm apply for the 255 decrement for this image. Okay, and I'm displaying for here is show share negative image. So just remove this, and first of all here I apply this is a negative image. So this is perfect, and now I'm create for just change for this title, and here I apply for the title name is called negative events. Okay, so this means for I'm used for again this load image using for image rate to create for here's a negative and subtract the pixel value from is 255, and this efficiently involved for the color and just for the negative image using for here is a matchplot libraries, this pipe plot. Okay, so now it completely done. Now just click I save this code. Just let's run again run this code. So just wait for here few seconds. It's populating for this image. So here's a publicly see this is negative image is perfectly here. Okay, so I hope you perfectly understand in this topic, and here I'm publicly explaining for this topic, and there you have it. It covers the basic image processing technique using for the NumPy and converting the grayscale and creating a negative image. So I hope this give you a good starting point for your own image processing process. Okay, so now thank you for watching and happy coding. Hi everyone, and welcome back to our today's tutorial on generating for random numbers with the NumPy. So this tutorial I'm created for cover the basic example and show for how to use for this NumPy powerful random number generation capabilities. So now let's get started. So first explain for the NumPy is a fundamental package for scientific computing in Python, and it includes a robust module for random number generation. So today explore for here is a generate number a random array and the random sample from the distributions. Okay, so first of all here is generating the random number. So you can see I'm inserted for the NumPy this package, and here I'm different generate a random number b2 0 and 1. So first of all here I'm type this is a random underscore this number, and it's equal to use for np dot define this number dot use this ran is not now. So use for perfectly this is up. You can see here I'm applies rand this method. Okay, so now here I'm used for simply the print function, and in this insert just type for here. You can see define for here is so this one is a random number between you can see between 0 and 1. Okay, so now it's a publicly defined, and then here on call for this is a random number. Okay, so this method here used for np dot random method to generate a random slot plot number between 0 to 1. And it is simply an efficient way to generate a number in this range. So now I'm just click all and save this code, and just let me run this code now. So as you can see here, C4 is a simply error because here is not defined this. So you can see just again for check this code. So for the first time I apply for random numbers np dot. Okay, so you can see here publicly false is big mistake. So then here I define this random dot use this rand method. So now just again save and then see the result. So you can see here perfectly see the result for random number for 0 and 1 and print for 0 values 0.49068 and something. Okay, so I have understanding now. Okay, so now is a correct output to just show for this console. So as topic here I'm choosing simply just define as a random generating a random array. Okay, so this means I'm just going for here and remove for this number and publicly insert this is 0 array. Okay, so in this insert I'm used for np dot at random, and this insert I'm used for the sum element is 3 and 4. Okay, and using for here just type for simply here I'm just type this 2-dimensional. So this means array of this random number between 0 to 1, and define for publicly inserted this is a new line, and then remove for this random. Okay, so you can see just remove this random number and insert for here the public random array, and then just here not now just write. Okay, So this means it's perfectly done, and here I'm used to generate a two-dimensional array with for three rows and 4 columns, and filled with for random plot number using for 0 and 1. This is useful for creating a data set or initializing metrics for its various applications. So now just save in this code and just let's run this code now. So just wait, and as you can see here, perfectly print for two-dimensional for this random array between this one. This means for this array is just straightforward. For this one example, for here is a draw the random sample from a normal distribution. So cipher only used for the two-dimensional array of random number. Okay, I be complete understanding. Okay. So now just move on for the last example. So here I'm creating the sampling from normal distributions. Okay. So first of all, I'm just here and remove this. So just remove for this normal random array, and here I'm just type this normal this samples. So just type for it. You can see insert for the sample, and then change for this element and only use for the 10 element. And then type for here, remove for two-dimensional this array. And first of all, here I'm type for random is a sample as just type for is perfect samples from normal distributions. So just remove, and here I'm apply for samples from normal for this three. So this P portion. Okay, so this makes it perfectly done. And now just do for this normal array, and here I'm inserting for this is of normal samples. Okay, so this means it's right for 10 random numbers from a standard normal distribution means 0 standard derivation for 1. Okay, so now just I'm saving in this code, and let's run this code now. So I'm just wait, and you can see here perfectly printed for the output. This one is perfectly here. Okay. This is a particularly useful is a statistical modeling and simulation. So, and there you have it for completely cover 3 basic example of random number generation using for the NumPy. Okay? So in this NumPy generating for simple random number, creating a random array and sample from a normal distribution. Okay, so I hope you probably enjoy in this session. So now just thank you for watching and happy coding. Hello everyone, and so welcome back to today's another topic. So today I'm creating for advanced indexing technique with NumPy. So first time I explain for NumPy is a powerful library for numerical computing in Python, and is advanced for indexing its capabilities allow for complex and efficient data manipulations. Okay, so today I'm expert for the Boolean indexing, integer array indexing, and also define for this code step. Okay. So first of all, I'm create here the Boolean indexing. So first time I apply is simply NumPy library, and first time create our own dimensional array of numbers from 0 to 9. So different assembly for this array is equal to use for np dot and then type for this array, and in this inside so just define this is arrays this method, and this inside element is a. And now I'm using for the indexing to filter out the even number. So just type for this is a even underscore. It's called as the number. Okay, and is equal to. So first I'm apply for array and use for the square brackets. Define for array module, and the module is equal to 0. Okay, and then here first is a print for original arrays. So just type for is called the original array. Okay, so this method is perfectly done, and I'm declare for the simply in this array, and now here is for another print function, and in this insert print for even number. So you can see it's just type for simply define is perfectly the even number and code, and create this colon and define this even number, this variable. This means is create an array of number from 0 to 9 using for this np dot arrays and use for element for 10 and use for the boolean condition for array and modules to equal to 0, filter out the even number. So select all and save this code, and just let's run this code now. So as you can see here, the result for original array is 0, 1, 2, 3 is a 9, and even numbers are 0, 2, 4, 6, and 8. So this result is an array is containing only so print the even numbers. Okay, so I have understanding. Okay. So next topic here I'm taking is the integer array indexing. Okay, so now just access for specific elements in an array. So you can see just going through here and just remove for this array. So here I'm inserted only in this array. Okay, and just remove this element. And first of all, here I'm used for is a square bracket. So first I'm defined for the 10, 20, and 30. So now here I'm inserted is for is a 3 row. So that's going for and again create is a 40, then 50, and also for the 60. And again use for this square bracket, and then one for the value our element is 70, then 80, and also take like this is 90. Okay, so this perfectly done. And then going for I'm using for integer array indexing to access for a specific element. So just going for here and real for this one, and just type for the selected elements. So say selected elements is equal to, so you can see elements and different for the array. And in this insert, first of all, I'm used for different for array, and the square brackets is different for values is 0, 1, 2. Second value here I'm different for another square bracket inside, different for the 2, 0, and 1. This one is perfectly done. And first I apply the original array and perfectly create this new line and call for this array. And so from create this is a selected element, so just remove and perfectly just type this is selected elements, and then remove this. So here I'm just remove this even number and define this selected elements. This means it's perfectly inserted now. And now just select and just select all and save this code, and let me run this code now. So just wait here. You can see firstly the print for the original array 10, 20, 30, 40, 50, 60, 70, 80, and 90, and selected element for 30, 40, and 80. So this means it's perfectly printed for this. The result is an array containing the specific element. Okay. So next topic here, I'm defining the slicing indexing step. Okay. So this is perfectly simple up code. So just I'm going for this code instead and remove this one. And first of all, I'm simply remove for this array and insert it for np dot use this arrange method and inside and define for the value or element distinct. Okay. And like using the slice indexing with a step to get every other element. So now just remove this, and here I'm type this is every so other underscore this element and define for simple array. Okay, so now apply for perfectly here is a double clone is a 2 element, and I first just print the original array and secondly print for this is every other elements. Okay, so every other elements, just you have selected elements and perfectly inserted for this every other element. So this means for it is simply create one-dimensional array of number from 0 to 9 using for np.array arrange method. Okay, so now just save again this code and just let me run this code now. So as you can see here, first the print original array, and here the every other element 2, 0, 2, 4, 6 is a print for every even number. Okay, I hope you're understanding this topic. So now is a slice indexing with this script. You did exactly the element is regular intervals, and they have it discovered for advanced indexing technique with NumPy. Okay, I hope you understanding for this whole topic. So now just thank you for watching and happy coding. Flavian, and we come to our tutorial on optimizing with the NumPy. Okay, so today we're going to delve into the world of NumPy. It's a popular library for numerical computing in Python. And here I'm defining for the NumPy can optimize the code and make our easy computation more efficient. So let's begin by understanding what the optimization means in the context of programming. So optimization involves for improving for efficient and performance of our code, making it faster and more resource efficient. So now I'm used, for example, involves for completing the sum of elements in a large array. So now let's take a look at the code. Okay. So first I'm defining already for this NumPy library and create here is a large array using for NumPy. So first of all, here I'm defining for array is equal to np dot define just is a random dot use this range method. And in this inside, I'm inserted for the value is a 1 and is a 6 0. So this one is a add so not now. So next time create for is a calculate the sum using for the follows. So first time apply the div and then type for sum underscore is for this with gain and then define for the div, and in this inside declare for this array. Okay, and now just going for here, and first of all here I'm just type this is total is equal to 0, and then repeat for again use for this for loop this number in this array. Okay, and so it's not correct. So this one is correct, and next time apply for this is a total, and then plus equal to this number. Okay, and next step here I'm used for perfectly just type is a return statement for this total value. Okay, so this means perfectly done, and now here I'm calculating for the sum using for the NumPy sum function. So first I'm going for here and then type for again this is div for declare this sum underscore is for this perfectly with, and again inserted this is a NumPy. Okay, so this means perfectly done, and in this insert I'm defining again this array and use for perfectly this return statement for np dot use this sum method, and this insert I'm defining again this array. Okay, so this means perfectly done, and now compare for the performance of the both method. So first time apply for is a print function, and in this insert print is a double quotation, and there's this type for sum with this loop and get this one and that inserted this is a sub with for this loop. Okay, and in this insert I'm defined for this array. Okay, so this one is perfectly done, and now just here I can just copy this code and paste for next line and change for the sum with for this NumPy. So I perfectly inserted this NumPy and change for the NumPy method. So define for here so just some type for you can see the sum with NumPy. So this means perfectly done. Okay, and in this insert I perfectly define this array. So this means for in this example for is used for two function on that calculate the sum using for this traditional loop, and another that utilized by the NumPy for building some functions. So now let's see the output. So first of all, you have saved all and save this code, and just let me run this code now. So I'm just wait here. I can see the results. So first the print for the sum with the loop is 9996868.2 something, and here is same result because the sum calculate using for NumPy is a significant for also is compared to the loop based NumPy optimized for functions are implemented in C, making them much faster than theirs. Python is counterproductive. I hope you perfectly understand in this NumPy is a powerful tool for optimization in Python. Okay. So now, so thank you for watching and happy coding. So I hope you perfectly understand this topic. Okay. So now just again, thank you. Okay. Hello everyone, and we come back to today's another tutorial topic. So today, performance for consideration in NumPy. Okay. So now let's get started. So in this, the highlight for optimization for your code for better performance easy for NumPy. Simply explain for this, NumPy is a powerful library for numerical computing in Python. So, but to get the best performance, you need to the way of ascertain participant and the technique and today explore for efficient array operation using for this NumPy. So first example is efficient array operation. It can improve for the performance. So first we apply only is NumPy library, and so imported for another library for this is a time. Okay, so this means done. And first we create for here the two layers of array, so different for arrays of 1 and is equal to np dot is this random, and then type is a rand, and in this instance I'm defined for this limitations. Okay, so now it's just I'm copying this code and paste for this next line and change for the array. So now define for array up to, and it's for the same this data. So create this parenthesis. Okay, so this means perfectly done, and now just change and it's a 2. Okay, and now here I'm create for element wise addition using for this loop. So you can see. So first of all, here type this is start. So start it's not correct. start is a start. Underscore this is a time and is equal to, so first time apply for time dot this time method. So next step here I'm type this is the result. Underscore is a loop and it's called equal to define for np dot 10 perfectly type is 0. Underscore is like method. Okay, and in this inside define for this array one value or element is done, and so here apply for simply just type is a for loop and print for I in. We sorted for perfectly this range, and this inside I'm different for length for perfectly this length inside I'm different for this array is 1. Okay, so this means that I'm done and going for next step and type for this is simply print for the result underscore this loop method, and I'm different for I variable. Okay, and it's equal to different for another array this one, and is for this index different for I variable, and create this equation for array 1 and different this array 2, and here I'm use again this I variable. Okay, and so here I'm create for simply the loop statements or loop underscore different for this duration. Okay, so this time type for perfectly duration different for perfectly time dot perfectly use this time method, and is to increment for time. Okay, so this means perfectly different for element wise addition using this loop, and now here I'm creating is element wise addition using for the vectorized operation. Okay, so first of all this route define for this is start time is equal to define this time dot again this time method, and so here I'm type this result underscore is a vectorized. So you can see for vector this one is perfect. Different supposed for inserted for array 1 and then additional operator, and this array 2 is almost is perfectly done, and then type for again this is a vector just perfectly typed, so is a vector rise. Okay, so vectorized underscore duration. Okay, so this is perfectly almost down at this code. Different for this time dot is this time method, and is decrement for the start time. Okay, so it's publicly done for vectorized operation and run print for these two operations. So first of all, here's a print function. First one print for the time taken with the loop. So different for this loop duration. And second print function here different for another. So now create the time take with the vectorized operation, declare this vectorized duration. Okay, so I hope it perfectly done in this code. So this means for in this code I'm explaining for again. So first of all, here is defined as a two layers array, and the purpose for here is the element-wise addition in this code using for both a loop. Okay, so here is a loop and a vectorized operations, and here the vectorized operations for the array 1 plus operator is significantly faster because it's leveraged for NumPy optimize it for the backend. So it's completely done in this code. Now just select all and save this code, and just let me run this code now. So just simply press this run button. So just wait. As you can see here, the first print for is the time taken with the loop duration for 1.167 is something, and here is a vectorized duration for 0.0.003990085 something. So I hope you some is print perfectly this code, and this means was perfectly done for these operations help for optimize for memory uses, and it can improve for performance by avoiding here in this code. Okay, I hope you perfectly understanding in this topic. So call for performance consideration in NumPy. So just thank you for watching and happy coding. Hello everyone, and so come back to today's other topic. So today I'm expert for is a significantly spread for NumPy code using for the Cython. Okay, so NumPy is popular for numerical computing in Python, but sometimes you need for state first, and that's where the Cython comes in this. So Cython is a super set of Python that allows you to compile for Python code into C for significant performance improvement. So today, explore for how to use for the Cython and NumPy to speed up the numerical computation. Okay, so first of all, here here's a simple example using for Python timing using for this NumPy library. So I already inserted for NumPy library, and here I'm insert for at the input. This is a time library. So first I'm defining is a function. So just type for a day, and the type is a sum. So this means sum underscore of underscore. This is a square. So square is a square, and in this instance I'm different variable of x. And then here I'm is for property is then a statement part in p dot. This is sum method, and this instance I'm different for this x and double multiplication sign for 2. Okay, so it's perfectly now done. Now it's right is a lower's array. So x is equal to np dot use for this random use for dot use this random method, and in this inside for large array define for. Okay, so it's perfectly done. And now I measure for this time. So first of all, here this start time is equal to is for this time method difference perfectly. And so now just type for another variable result is equal to different for the it's not price. So here my apply for is underscore the square. It is instead I'm different for x is variable. Okay, and also here I'm different for the end is equal to apply for this time method is perfectly done. Okay, and here I'm used for is simply this print function, and print function I'm create for f string, and so different for the print function of function type is f, and double quotation instead I'm different for perfectly is called the result, and now here I'm used for this square bracket and different this result. Okay, so this time type is perfectly it's not correct, so this is a result. Okay, so done, and now here I'm used for the print function, and first time I apply for if and double quotation and type for is time taken. So time for this taken. Okay, and get this clone and export this color bracket. Suppose just in this insert define for end decrement for this start to start timing, and here I'm inserted this is for this second. Okay, so this means perfectly done in this code and perfectly apply for Python optimization. And I'll just say in this code, first of all, let's hit this code and just let me run this code now. So just as you can see here, process print for the result is this one, and time taken for is 0.000603 and 652, and also the second, and I have completely understand. So as you can see, you're taking a considerable amount of time to compare, and it's optimized for using the Cython. Okay, so now here I'm create for another example. I'm create for Cython optimization. Okay, so Cython is afraid of the function supposed to create for are you create for py.py file with Cython implementations, and I'll just red going code inside, and I'll just code update for Python script is for script for use for the Cython function. Okay, so you can see I'm only used for this time input library, and here I'm defined for another library. Suppose I'm defined is from, then type here is a sum underscore is so of underscore then square underscore perfectly is a type is of Cython. Okay, and I'll just time use for input for perfectly just type the sum underscore of underscore then pairs this Cython. Okay, so if you are perfect understanding, and then going for here use for derived this large array for np dot, so you can see, so now this terminal for this function. Okay, and I'll simply apply for this x is equal to, and this is authorized large array, and I'll just measure for this time and use for the same this time, and so I'll also add for here is a Cython. Okay, so this is perfectly done, and I'll also see as it is, and going for here this result time taking with so now just change for this output message with for this is Cython. This means perfectly done, and is for the and start this second. So this means it's print for perfectly for the Cython code, and here is a Cython significant reduce the computation time is compared to pure Python. So here you can perfectly take this output, and I hope you perfectly understanding and work out this tutorial. So and you have it by leveraging this Cython or significantly speed up NumPy computation, and remember whenever its performance for Matter and Cython can be used a powerful tool in your Python toolbox. Okay, so stay tuned for more tips and tricks for in future videos. So now just thank you for watching and happy coding. Okay, hello everyone, and so come back to today's another topic. So today I'm deeply for exploring integrating for NumPy with other libraries. Okay, so now just I'm covered for the demonstrate for NumPy can work with seamlessly with other powerful libraries in Python ecosystem. Okay, so now simply explain for the Python series of NumPy is a foundational library for numerical computing in Python, and is a versatile allow you to integrate with the many other libraries. Okay, so today I'm explore for the integrating NumPy and with this pandas and math library. First of all, I'll place integrating NumPy with the pandas this libraries. So first I'm going for here import for another library. So just create this import for pandas as PD. Okay, and then go for this time create a NumPy array to different for data is equal to create for an np dot use the random dot publicly used for random method. In this insert I'm different for element for 5 and 3. Okay, and I'm convert for NumPy array to pandas data frame. So use for df is equal to first time type is a type pd dot apply for perfectly is called the data frame, and this insert I'm different for the data, and also here I'm creating this is a columns. And now in this insert, I'm defining for the square bracket. So first I'm defining for the value of the element of A, and the second for the character of B, and also for the character of C. Okay, so it's a publicly defined. And then here, and just open for this output, so publicly just apply. You can see is this print function. And first of all, I'm printing for the NumPy array. Okay, so you can see just define for this NumPy array, and create this column and define also this new line and dig for this data. And just again use for just gain inserted this print function, and in this insert print for is pandas. So pandas for this data frame create column, and also create this new line and just apply for this TF. Okay, so this means create for is a 5 into 3 NumPy array of random number using for np dot and brand, and then convert for this NumPy array into pandas for data frame. And this allows us to leverage for pandas powerful data is manipulations capabilities while maintaining the numerical efficiency of NumPy data. So now the verifying this code, first of all save all and save this code and just sit around this code now. So just open this, you can see here is publicly see this all results. First is a NumPy array, and this one is here. So it's a first print for NumPy all array element, and secondly print for the pandas for element and B element and C element. Okay, so I hope you perfectly understand it. So this is perfectly done. Is it completely useful is a NumPy with pandas libraries, and its topic here I'm used for is the most important is at the integrating for NumPy with Matplotlib library. So Matplotlib should visualize NumPy data. So first I'm going for here and simply import for is a Matplotlib library. So simply I'm just type is a Matplotlib dot inserted for publicly pyplot as a plt. So it's publicly done. And so I'm simply create a NumPy array of values. So here I'm just run this code. And first of all, I apply for x is equal to. So public is just is equal to define for np dot is for publicly this line space, and this insert inserted for the value first time 11 is 0 and second is 10, and also for is a 100. Okay, so now you create another variable of y is equal to np dot use this line. This method inside define for x variable. So done is perfectly. And so I'm going for and put the values and using for Matplotlib library. So first is time apply for plot, tlt and plot. And this inside I'm define first is x variable, second y variable. And also here I'm define this is sequence is a level. So just publicly type level is equal to is for single quotation, and in this define create the expression for sign into x. Okay, and so here I use for again plt define for is a simply x level. The x level means for x variable, and also here I'm create for another plt dot define is y level. It's a define for. So first of all, create this parenthesis and single quotation inside and define for sign into x variable. Okay, so this means perfectly done. And here I'm also created for is a plt define this title, and insert for title name is a sign less. Okay, so can see here is perfectly done. As right here I'm also created is a plot dot use this listen method, and mostly I'm apply for plot dot here is a show method, and perfectly save for the result is in this train. So this means here I'm again explaining for this code and apply and create an array of 100 value space between 0 and chain using for np.line space, and then compute the sign of these values using for np.sign, and finally just use for the matplotlib library. Now I'll just unsave or unsave this code and just run this code now. So I'm just wait here for a few seconds. You can see here, so the result for is open for graph for sine wave, and in this the matplot makes it easy to create here the visualization directly from the NumPy array, and allow you to quickly analyze this present data and see here performance numerical computation with the perfectly. Okay, so this is a sine wave graph. This is the x value and y is a sine x value. So I have been perfectly understanding this code and this output. Okay, so I was completely done for today's tutorial, and here I'm created for the NumPy on small libraries method algorithm, providing for a powerful tool for scientific computing. Okay. So now just thank you for watching and happy coding.